Thank you, Mr. Nirmal Kumar, for that. Thank you, Mr. Nirmal Kumar, for that captivating session on body prevention device to save lost lives due to catheter-associated urinary tract infection. Your presentation was highly engaging and we truly appreciate the knowledge and experience you have shared. Now I'd like to invite Head Design, Professor Praveen Mukhopadhyay, for presenting Memento as a token of appreciation as well as certificate. Mr. Nirmal Kumar. Let's thank Mr. Nirmal Kumar with a huge round of applause. One announcement that it is requested to all the volunteers and participants to carry your ID cards as well as lunch coupons while visiting the visitors hostel dining area during lunch. It is required today. Now, after a short tea break, we now continue with our second session of the day. We are honored to have with us Mr. Sudhir Tripathi, Director and CTO of Inochi Care. Mr. Tripathi serves as the Director and the Chief Technology Officer at Inochi Care, a medical startup focused on innovative wound care solutions. Before founding Inochi Care, he earned a strong background in biomedical engineering and healthcare technology. With a BTech in mechanical engineering and an MTech in mechatronics from IIT Jabalpur, his research and work focused on developing medical devices such as InnoHeal, which uses biomaterials and nanotechnology to treat chronic wounds, including diabetic foot ulcers. He has received several awards, including the Young Innovator and Entrepreneur Award from the Indian National Academy of Engineering. Additionally, he led the development of the wound care IoT solution for chronic wound monitoring. The session will be followed by Q&A. I encourage you all to actively engage during the same. Please join me in welcoming Mr. Sudhir Tripathi with a huge round of applause.
Hello everyone. I think first I need a few minutes to let all of this sink in because this is a very different feeling, not sitting on those benches over there and standing over here. This is kind of the second innings, feels like a different stage of life. So I'm from IIT DeW Jabalpur. I've been here, I believe, I have the record for the longest student presence in IIT DeW uninterrupted. So I came here in 2007 for my bachelor's degree. Then under Professor V.K. Gupta and Professor Tanuja Shore, I did a project, the MHRT-led project on virtual labs, and then I did my master's again from here only. So that I believe has the longest continuous presence of any student in this campus so far. So at present, I am the director of Inochi Care Private Limited. Inochi is a Japanese word which means life. So we are developing technologies that will help in making lives of patients as well as doctors and their caretakers easier. The first product that we have launched in this vision and mission is InnoHeal. It is an advanced wound care device that helps in treating of complex wounds that would otherwise take very long to heal, and it helps in faster treating of those wounds. I will discuss each of these things in a lot more detail as we go ahead on this presentation. So InnoHeal is a Class C medical device. In medical devices, there are separate classes which define the complexity and the risk that is associated with that device that the patient might endure. And starting from Class A all the way to Class D, the complexity and the risk of the devices increase. So you must have already underwent several sessions within this workshop that help you understand how do you move from an idea to a product. In this session, we will try to focus more on how to make sure that those products do not fail that products remain technically sound, that products work even when they are exposed to extreme conditions in the field. So I'll try to cover some of those aspects in this presentation going forward. Now, before we begin, who am I? So my name is Sudhir Tripathi. As I mentioned, I came to this campus in 2007. Actually, we came to this campus in 2009. Earlier, for the first 2 years, we were in a different campus in JEC Jabalpur. That is when we saw how an institute is built from scratch. Our mentors and teachers present over here, the professors guided us not just in academics, but in building our character, in building a student community over here, in building a complete structure on as to how academics work, how physical development in terms of sports and other activities work, how the cultural development in terms of dramatics, music, and other societies work. And they instilled in us a process by which we could form teams amongst ourselves, we could work together, and we could make good progress academically for personal life as well as technologically in bringing out new ideas onto the table and onto the fields. So some of the things that we remember distinctly that were very different from any of our other friends attending different institutes were, for example, we had a multidisciplinary syllabus that many of you still follow. Even as mechanical engineers, we were supposed to understand data structures and algorithms. We were supposed to understand how programming works. And even when we use CAD software, we also had courses on what is going on at the back end of those CAD softwares, what makes SolidWorks works, so that we could have a better understanding of how all of those things integrate. And those kind of courses have been very crucial in helping us understand how things work, in helping us make new products and develop new technologies, because there are several things that will be solved in the hardware by buying better sensors, by buying better actuators. But there will always be some limitation to those things. There will be certain things that will be solved through software. But there will always be a cap to that as well, because you will have some limit on the processing power. And you need to understand all of those limits to make a product that functions well and gives the correct results. It also helps you understand what your limitations are, what your capabilities are, and you can combine all of that to make good products from different domains and different approaches. So, for example, when we talk about photography, Apple and Google use a lot of software processing on their cameras. On the other hand, Sony tries to develop very high quality sensors so that they require very less amount of software processing. Both of these approaches bring the same good result, that is a good quality picture that you love to share with your loved ones. But since the approaches are different, you can know that, okay, this is the sensor that I can afford, and after that, this is the kind of processing I will have to do to get the good results. But in order to actually achieve that, you will have to understand how the software and the hardware work together, integrate together. This goes on to the electronics, the PCB part of it, the electronics part of it, the circuitry part of it, as well as the physical mechanical construction part of it. So all of those things we were able to learn at IIIT only. Then towards the team building exercise, I remember that we used to undergo a design and fabrication project. This was a 1 year project that used to run on 2 semesters. We had to identify the needs, we had to identify the solutions, we had to identify how the users are going to interact with all of those things, and all of that comprised of the design phase of it. Then we also had to manufacture it so that we understand that if we make very complicated designs, they would be very difficult to manufacture. If we make very simple designs, they might not be able to meet all of the user requirements. And in order to execute that project, we were supposed to form teams of 3 members, one from software engineering, one from electronics engineering, and one from mechanical engineering. The other 2 restrictions were these 3 people could not be from the same state, from the same home state or hometown. The other requirement was these 3 people could not be roommates. So we had to go out of our way, talk to our teammates and classmates from completely different domains, from completely different backgrounds, from completely different geographical locations, and that brought out the ideas that we otherwise from a very small geographical location, from a very small frame of mind, would not be able to generate amongst a small group. So these kind of activities that we went through early on helped us understand different perspectives, helped us understand how to communicate better with our teammates, how to put our vision onto the table clearly so that everyone in the team could understand what we are trying to do and we are trying to achieve. I believe most of these things are still going on, and this is an excellent opportunity for all of the students to learn all of these things while you are students over here, so that when you get to the field, when you get to the industries, when you start your own ventures, you are able to execute all of those things much better. So with all of the groundwork laid down for us in terms of the course structures, in terms of forming of the teams, in terms of the projects and access to hardware and facilities within the campus, we learned a lot of things. We did projects within the campus. We did projects working with Jabalpur Police. We worked on several other industry projects. So these are some of the projects that I personally worked on. Some of the other teammates and some of the other batchmates worked on several other projects throughout various domains in the industry. All of these things again gave us a much clearer idea on how to integrate things, how to make things work, what will be the limitations of the industry, what would be the limitations of the facility that we are in. So for example, right now you see such a big campus with varied labs with a different lecture hall complex. When we came to this campus, our labs were not this big. We did not have so many machines, so many facilities. Even the lecture hall complex had not started construction at that time. So our lectures used to be conducted in the core lab complex itself. At that time, only two buildings were here. The core lab complex was constructed, and then we had hall one, out of which three or four wings were functional at that time. The D and E wings were constructed afterwards. So within those limitations itself, we were given free hand and access to use any and every machine that is available over here. We were allowed to have hands-on sessions with those machines so that we can actually understand the complexity of manufacturing and the complexity of fabrication of anything that we think of. And this helped us find simpler, faster, easier, cheaper methods to make something that would otherwise be very complicated or very complex to make. For example, on the bottom right corner, you can see a humanoid robot. This robot was built completely in-house using the cheapest servo motors that were available in the market. And for making this robot, we bought an aluminum sheet from the local market. We used the water jet cutting system installed in the NXA over here, and we cut out all of the parts. Then we used the Amada bending machine that is available within the campus to build the entire frame and body of the robot. And then we assembled it entirely in-house, and this helped us understand what the processes undergo and what things we can do much cheaper. Had we not gone this route using the facilities within the campus itself, we would have had to get the structure 3D printed or buy it off the shelf. So the kind of cost reduction and the kind of understanding of manufacturing progress that it brings is, this entire robot was constructed with the total cost of somewhere around 25 to 30,000 rupees, and the cheapest off-the-shelf robot that we could buy so that we could just program it and understand how humanoids robot work was, I believe, an open source robot that was available for somewhere around 1.7 to 1.8 lakh rupees at that time. So having all of the facilities, having access to all of the facilities, and actually being able to understand how things work helped us create this robot for a much smaller price. If we wanted more of these robots for more teams to work on, we could easily replicate 5 or 6 of these for the cost of just one single robot that we could have purchased from the market. So with all of these information, with all of these learnings and some small wisdom that we could gather at that age, I graduated from IIT DeW Jabalpur, and for a good measure, I did it twice. So I got my bachelor's in mechanical engineering in 2011. Then I did my master's in mechatronics engineering in 2015. So once I completed this entire process at IIT DeW towards the learning and gaining wisdom and gaining technical prowess. The next question was what to do next, where to apply this knowledge, where to actually build something that gets used within the system, that gets used by the people, that gets used within the community around us. And this vision also was instilled during my master's program itself, where we worked on a project for Jabalpur police, in which we tried to make an entire system which would stop the heavy vehicles entering into the city. And if any vehicle tried a forceful entry into the city, the system raised an alarm at the police headquarters so that the vehicle could be tracked on time and any damage to the civilian population or the civic structure could be stopped as early as possible. So understanding that we were reading about and learning about the cutting edge technologies that are implemented worldwide, and then having to implement something that is robust enough to withstand field forces, temperatures, fog, dust, everything, and still work functionally with mischievous people trying to break the system, with mischievous people trying to bypass the system, trying to find a solution that is not just a technological concept but actual field solution that works on the field. That brought a very different approach to solving problems and understanding the entire value chain of the product, not just simply a technological structure of the product that comes naturally to us as engineers. So with all of these things, I started looking out for ventures and started looking out for opportunities where I would actually get to build a hands-on product that would be used by the users at the end, and I would get to witness where exactly those products are used, how those products are used. And applying for several such opportunities, I finally got to attend the SIB Fellowship. This is the School of International Biodesign Fellowship, which was earlier the Stanford India Biodesign Program. This fellowship is run by AIMS New Delhi and IIT New Delhi in collaboration with universities from Australia and Japan. And we were lucky enough to attend this fellowship with fellows from various countries. So we had fellows from Australia, Japan, Nepal, and other geographies as well. These fellows, similar to the design and fabrication projects, came from very different fields of understanding and learnings. Our team comprised of people from mechanical engineering, electronics engineering, design, biotechnology research, medicine, as well as surgery. So our teammates were, for example, we had Dr. Tahir Fuji, who was an ENT surgeon from Japan. We had Miss B. David, who was a nurse from Australia. We had Dr. Shivani Gupta, who was a PhD in biotechnology from BITS, Hyderabad. And then there was me from IIT DeW Jabalpur with information on electronics and manufacturing. We also had people who were experienced in design. We also had people from biomedical engineering. So during this fellowship, what we actually did was we underwent immersion. So I believe in the previous session, Nirmal has already spoken about finding out the problems, identifying the needs, and identifying the user requirements. All of this process happened during the immersion where we shadowed the doctors. We were present in surgery rooms, we were present in PHCs, we were present in CHCs, we were present in the waiting area outside clinics and hospitals. We spoke to doctors, we spoke to nurses, we spoke to ward boys, we spoke to the patients, we spoke to the family members and caretakers of the patient, so that we can get a very thorough understanding of the problem and how it impacts each and every person. We also went from the Apex Trauma Center at New Delhi, which has world-class facilities, to a very small PHC in a remote village, which barely had tables and stethoscopes for the doctors to assess the patients. And we tried to understand what kind of problems do the healthcare channels in India and worldwide face. Identifying these problems, we also got an opportunity to visit Totori in Japan and QUT in Australia, where we again went to several hospitals and we got a very comprehensive understanding of the medical and healthcare problems, not just from the Indian perspective, but also from the perspective of Japan and Australia. This helped us understand and identify what kind of problems are there which are available throughout the world, which the patients suffer from throughout the world, and solving for those problems would make a global solution, not just for India, but applicable to the entire world, made in India. With these things in mind, throughout the fellowship, we identified the need, we developed the solution, we filed patents, we uh, developed the solution from a very ideation stage to a proof of concept stage. But that is all that could be done within the confines of the fellowship, within the duration of the fellowship. So once we were convinced that the problem that we are trying to solve is a very important problem, many patients suffer from it, and it needs an immediate solution, we decided to form our startup, InnoCare Private Limited, and with this startup, we started developing the solution that was ready for the field, that was ready for the patients, that was ready to be deployed in the field. The doctors would be able to use it and the patients would actually get benefited from it. But this journey was a bit more complicated than we had initially anticipated and we initially had understanding for. So a very small summary of this journey is available within this slide. Our company was founded in 2017. We started working in advanced wound care, which was a problem that was not just in India, but it was a problem globally. So when we talk about advanced wound care, there are several wounds that take very long duration to heal. These wounds get infected again and again, and it requires a lot of attention from the doctors, the caretakers, as well as from the patients to actually get those wounds healed in time. And the complications of not getting those healed in time are very severe, that are described further ahead in the presentation. So working in advanced wound care, we came up with a solution that we wanted to implement. Once that solution was implemented to a initial proof of concept stage, we started to understand what it takes for the solution to come out from a bench test, which are the kind of solutions that we do in our BTech projects, which are the kind of solutions that we build during our engineering classroom programs, and to convert it to a field ready product that can actually be deployed on the field. Within this process, we received an ISO 13485 certification. So ISO 13485 is very similar to ISO 9001 quality system certification, but it is targeted towards medical devices. Having an ISO 13485 means that your facility and your processes are robust enough, designed in enough detail, and structured well enough so that anyone in your team following those processes will make a quality product that will not fail and will work properly in the field. With the ISO 13485 certification for our R&D facility as well as our manufacturing facility, we set up our own manufacturing facility, which in India turned out to be a very difficult challenge. So we had to understand all of the government norms in terms of setting up the industry. We needed to understand all of the government norms in terms of the quality systems in place. We needed to find people who would be able to make all of the installations and set up in the offices and the manufacturing facility so that all of the manufacturing processes and assembly processes could be completed correctly. We also needed to find out vendors who would provide us quality products. We needed to design our own quality systems in check in order to identify that each of the components that we received was of good quality and it will not fail 2 years or 3 years or maybe 2 months or 3 months down the line. So with all of those sorted, we had our manufacturing facility ready. Within this time, we applied for patents for the technologies that we were developing, and we received the patent for our technology in India, Japan, USA. The UK patent is still in progress, and we got the design registered within India. So these are the IP protection mechanisms that we started to put in place, so that once the product is ready, we can actually sell it into the market without having unfair competition from people who try to steal our technology or our ideas. With this, all of these things in place, we applied for licenses from CDSCO to manufacture and sell the Class C medical devices. So CDSCO is the central body in India that licenses out or gives permission for the industries to make medical devices. Any medical devices uh, running in India fall either under two categories. So they could either be unregulated medical devices that do not cause any kind of harm to the patient, that do not cause any difficulty in the entire diagnostic or therapeutic procedures, and these products might only need a registration with the CDSCO. So the company only has to tell the CDSCO body that okay, we are making these products. In our case, the device has a potential that if the device is not working well, then there may be harm to the patient. If the device is not available, then there may be harm to the patient. So that increases the level of risk and complexity for the device. So for our device, once we applied to CDSCO, they requested all of the development documents, all of the documents towards testing and reliability of the products, and after that they decided to visit our facility as well. So they inspected our facility, they inspected all of our processes, they inspected all of our mechanisms and quality checks, they inspected our devices, and they also had interactions with our team to understand that okay, uh, each and every person has been assigned the responsibilities and duties as per their skills and their understanding of the product. With all of this inspection and monitoring process completed, we received our CDSCO license to actually manufacture and sell the devices within India. With these devices, we also did our clinical studies at AIDS, where several patients were treated using our devices, and the results were very good. Many of those patients healed quicker to the standard process of wound care that was available. And during this entire process of setting up our company, not just a product, not just building a product, we also were lucky enough to receive recognition for our efforts. We received the IAE, that is the Indian National Academy of Engineers Young Entrepreneur Award. We won the MedTech Innovator Award in Tokyo. After that, we also won the MedTech Forum Asia Pacific in Singapore. We got the AFI Best Social Enterprise in 2019. We were also the winners of ASME ISO in 2022. We received Wagner Award in 2018, and we also received the Thai Global Award at Dubai in 2021. So with our confidence boosted with all of the support and recognition that we were getting, we were further, I'm not sure how to put it into words because this was a very happy moment for us. So our clinical mentor, Professor Sushma Sagar, she had submitted her research for regarding treating of the patients with the devices that we developed under her mentorship. She had been crucial in helping us understand the entire scale of the problem, the effectiveness of the solution, what kind of requirements were had to be incorporated into the devices, and once we had working testing machines that were certified to be used on the patients, she was the one who led the charge of testing the machines on the patients and ensuring patient safety at each and every point throughout the entire clinical study. Earlier this year, she received the AIMS Research Award for Best Technology Innovation on AIMS Research Day. And we were humble enough, and we were humbled by the recognition we got. We were featured on Z News, DD News, and several other newspapers, covered the importance of this machine and the kind of benefits it brings out to the patient. Now, with this introduction of what we are doing, I would like to come down to what is the actual problem that we are solving and how did we got to the entire process of from finding out the problem to actually reaching out to this stage where our product is actually being used on patients and bringing ease and happiness and faster recovery to the lives of these patients. So the first stage was understanding the problem and finding the problem. As I mentioned in the clinical immersion stage, we were in all of the various settings in the hospitals. We talked to doctors, we talked to patients, and we tried to understand what kind of problems the patients and doctors face. And this helped us identify many number of problems. The next the next stage of going forward was to then find a proper problem worth solving. When we say a problem worth solving, there are thousands and thousands of problems in each and every domain in India, in healthcare, in technology, in education, and each of them needs to be solved. But not every problem can be solved. Some of those problems have very complicated and very expensive solutions that are very difficult to scale. Some of those problems already have solutions that the users are not willing to adapt to, or users are not ready to use. So we had to identify a problem that many patients suffer from, which was technologically possible to solve, which would make a sustainable business, so that once we solve the problem, there is not a hurdle in actually bringing this problem out to the public, to the patients, to actually heal their wounds. And with all of those things in mind, we identified that the wound care was a big problem. Patients, right from the largest, the topmost creamy layer of the society, all the way to the lower and lower strata of the society, were suffering from some or the other kinds of wounds. Some of these wounds are caused by road traffic accidents. Some of these wounds may be caused by industrial accidents or workplace accidents or workplace mishaps. And a large part of these wounds are then further caused by lifestyle problems and lifestyle diseases. So the next slide that I'm going to show is a graphic slide. It has a picture of
bedridden patients.
yes, ma'am. Even the bedridden patients suffer from bed sores. So those patients also suffer from wounds. Even after surgeries, there are surgical site infections that might occur. And after a large surgery, which requires clearing up of a large part of the body, that also there also might be wounds which undergo infection and require assistance in getting them healing properly.
So, how many such type have been clinically tested by?
So, ma'am, the underlying criteria for these wounds are already defined and already understood. The clinicians, the treating clinicians in terms of general surgeons, diabetologists, and even plastic surgeons or orthopedic surgeons understand that if the patient has these underlying conditions, then there is a possibility that their wounds will take longer to heal. Further, while they are operating on the patients or they are observing the patients, they are able to assess, looking at the condition of the tissue, that these wounds might get infected or get complicated. Otherwise, there are also biological evaluations where they take a swab culture, they take some amount of fluid or tissue from the wound, and then they culture it to identify the kind of bacteria and the kind of other infection causing agents that might be growing there. And a lot of those information define the kind of treatment that would go on ahead.
So even if it is not visibly like to an ordinary man, not so visible, it is.
In most of the cases, it is visible to everyone, but the clinicians understand that what complications can be caused from what visibility of the wounds. So, for example, if the wound is very healthy in condition, then it remains red in color. So that presence of red color means there is proper blood supply to the wound. There is ample amount of nutrition and oxygen availability at the wound site, so that there are less chances of infection, and there is a higher chance that the wound will actually heal and close well. But in some conditions, if the infection has already started, there might be chances where the wound might have some yellowish, mucousy, sloughy substance going on there. There are also, in extreme cases, some black tissue marks that are there on the wound, and these black tissue marks, that these black sections of the tissue means that that tissue is already dead, and that has to be removed for the new tissue to grow in and the wound to become healthy. So in the next picture, there are some of these wounds that happen to patients. These pictures are graphic and they show open wounds. So if you guys are not comfortable, you can avoid looking at the slide. I'll tell you, I'll just open it for a couple of minutes only. So the first two images over here are for diabetic foot ulcers. Many of the diabetes patients undergo a small wound or an ulcer on the foot, but since their neurological pathways are impaired, they are not able to know before this wound becomes very severe. There are also venous leg ulcers where the blood supply to the peripheral, the limbs are impaired, and the wounds do not heal properly, then there are several surgeries or there are road traffic accidents or other kind of accidents where there are open wounds or amputations, and those regions of the tissue have to be closed. And then there are pressure ulcers where if the patient is bedridden for a long duration of time, then the skin over there starts to macerate and die, and that creates an open cavity which becomes very difficult to heal. And since the patient is bedridden, that entire area is always the area that is under pressure, that accumulates sweat, that accumulates heat, and treating of that section of cleaning of those wounds, treating of those sections of the wounds always becomes a very large challenge for the patients as well as the caretakers. So I believe those images were clear enough to the kind of pain it provides to each and every patient that suffers from those kinds of wounds. But that is only one part of the story. The other part of the story is the scale of this problem, not just the intensity. There are over 77. So actually, this is the old data that we used in our earlier presentations. At present, with the latest data coming out earlier this year, there are over 100 million people who have diabetes in India. More than 15% of these people, somewhere around 15 to 25% of these people, suffer from diabetic foot ulcers. And these ulcers, once they occur, they take several months to heal, if not years, if proper assistance is not provided. And in very extreme conditions, the people suffering from these diabetic foot ulcers have to undergo amputations. There are several patients who get their toes infected or their toes die out and they have to be removed in order to prevent the rest of the body from catching out that infection. Apart from that, there are about 52 million hospitalizations, with many of them being completely bedridden or immobile. For such patients, the ideal protocol is to have the patient turn or move the weight of the patient to the side of the patient in every 2 hours to 3 hours, depending on the weight of the patient and the condition of the patient. But it is not possible, or physically there is not enough caretaker or nurse to patient ratio in the Indian hospitals or even at home for several patients, that such kind of attention to be paid to each and every patient. With the working population, people going out to offices, even for the lower strata of the society, where each and every member of the family is working, it is very difficult to for someone to be available with the patient and switch their position every 2 hours. Once these bed sores develop, I remember for some of my relatives, the doctors saying that these sores cannot heal. They will go away when the patient goes away, and that was very difficult at that time to hear. But as we learn more about these wounds, it is in fact a problem, because for many of the patients, these wounds never heal. After that, there are close to 50 million surgeries happening in India annually, and many of these, after surgeries, these patients develop surgical site infections, because once the surgeries are completed and even if the wound is closed, that wound requires a lot of care in terms of cleanliness, in terms of disinfection, in terms of dressing it regularly and changing the dressing. So in many of the cases, the nurses are not available. In many of the cases where patients are sent back home after their surgeries, the home the home care facilities or the nurses visiting their home to change the bandages regularly is not available. So where these bandages should be changed every 4 to 6 hours, these bandages actually get changed only when the patient revisits the doctor 1 to 2 days later. So these kinds of wounds again become a site where the infections might occur, and it becomes very difficult, because once that infection has occurred, there is no way that the wound can heal. So the doctor has to remove that infection. Sometimes removing that infection means just cleaning the entire wound area with an antiseptic solution. But in other extreme cases, it might also mean that the doctor has to cut away the entire tissue that is infected, because that is the only way the entire infection can be removed, and that is the safest way for the patient. But this also means that the wound size has now grown, because earlier the wound was small and it was infected. Now to remove all of this entire infected area, more tissue has to be removed, and the wound has in fact become larger, which now will take longer amount of time to heal and which now requires a lot more care for actual healing of the entire wound. So in order to solve this entire problem, we created InnoHeal. So InnoHeal is a multi-therapeutic wound healing device. It is an advanced technology which takes two basic wound healing technologies. First is the negative pressure wound healing technology. This means that the device provides a very small amount of suction pressure at the wound so that any exudate or any liquid that is coming out of the wound that becomes the food matter for the bacteria to grow on, that becomes the cause which leads to infection. All of that can be removed. This keeps the wound dry. This keeps the wound clean so that there are no further infections. Further, this applies a kind of pressure, pulling pressure, which tries to bring the amount of the edges of the wound closer to it, and it also applies. It also aids in angiogenesis. So angiogenesis is the process of the blood vessels going towards a particular direction. So that small amount of pressure that is applied helps in the formation of blood vessels towards the wound area, so that any of the blood vessels that were impaired due to the injury or infection, those can be restored, and this further leads to the easier and faster healing of the wound. The other technology that we apply is.
So you mean to say that this requires some oxygen to be supported with some oxygen unit as well?
Yes, ma'am. So there are two parts to the technology. So one part is the actual sucking out of all of the exudate and infection-causing agents around from the wound area to keep it clean. The other part is then bombarding the entire area with oxygen.
Okay.
So we make a low-pressure, oxygen-rich environment in which there is direct interaction of oxygen from the skin. So like the skin breathes, the tissue, the open cut wound tissue also has some amount of oxygen exchange from the surroundings. So by creating a localized high oxygen concentration environment, we are able to increase that interaction of oxygen with the tissue, and oxygen further reduces the chances of uh, infections and anaerobic infection. Sorry. So oxygen further aids in reducing the chances of anaerobic infections, anaerobic bacteria causing the infections, and it further heals aids in faster growth and faster healing of the tissue by direct interaction of oxygen with the tissue.
So everything is within this unit, or?
So ma'am, the entire unit has three parts to it. The entire system has three parts to it. So one part is the device that we are using. So this is the electronic device, this controls the entire therapy that is going to be applied to the wound area. To actually get this therapy onto the wound area, we have a dressing system like shown over here. So this dressing system is laid onto the entire wound. Then through tubes, these are connected to the device. Behind the device, so behind the device, if you can see over here, there is a collection canister that is integrated into the device. This collection canister holds all of the exudate that is coming out of the device. Within this canister, we have antimicrobial filter so that this infection-causing agents cannot enter to the device and they remain within the canister only. And we also have a solidifying agent within the canister so that all of the liquid that is coming out into the canister gets solidified there only, and it does not leak out of the canister when the canister is replaced or the dressing for the patient is changed. So after the dressing and the canister, the next part of the device is the oxygen supply. So in order to make the device usable across all the healthcare settings and minimum requirement for new products or new items to be added, we made the entire device compatible with the wall oxygen units available in each and every hospital. So we have a connector that plugs into the current oxygen supply units within the hospital, and the other part of this connector enters to the device. And then the other tube from the device goes on to the dressing, where it is able to provide the oxygen directly to the wound. So one of the challenges within this device was to control the suction part of it, that is the negative pressure part of it, and the oxygen supply part of it, so that the wound is in low pressure but still rich in oxygen. The oxygen supply should not go out directly into the suction unit, so that the volume of the oxygen unit there itself is able to aid the patient. The other challenging part of it was to control the flow rate of the oxygen as well as the suction rate and suction pressure in such a way so that providing the oxygenation does not reduce the pressure that we are applying, and providing the suction does not reduce the amount of oxygen that we are supplying. And blessed with the knowledge that we had received over here in terms of understanding the hardware part of it, in terms of understanding the actuation, the valves, the pumps part of it, in terms of understanding the sensors and electronics part of it, and then the software part of it, we were able to execute the entire project where we are able to control the flow rate of the oxygen simultaneously with the suction, so that we are able to achieve the proper environment for the wound where the wounds can heal faster and the infections can be reduced. So this part of it, I'm not the correct person to explain.
Is it safe to say that all of the free radicals which are there over at that area are utilized with the oxygen?
Uh, Not entirely. So when we are talking about the presence of oxygenation, what it is doing is not just chemical reactions eliminating any of the radicals over there. What it is more essentially doing is it is providing more oxygen directly to the tissue, which uses that oxygen for its growth, for its energy generation. So once the tissue is deprived of oxygen, the tissue will start to die, and the deprivation of oxygen happens because the blood supply to that region